right here we are setting up the ring, a new precision for this 3D scanning of the Micro 2. I took a small little pin that's like the size of 5 millimeters in length, and I basically scanning the glass where it comes together in the top of the scanning area. If you notice when the scan is done, this is sped up and it is doing a total time of this entire scan process of 6 minutes. We'll get this STL file completed. We'll just keep watching the scan, go through the process. It is sped up, like I said, but this first process of scanning is a 4 minute process, and then me actually cleaning up the rest of the file took 2 minutes. So 6 minutes total to get this file ready for export. And we are finishing up here with the scan, looking at the actual scanned data. I'm going to start cleaning it up by going into the editor and clicking on the erase, clicking the lasso, selecting only my object that I want to keep. I then go into the autonomy aspect of auto mode, and I can add the fusion and registration, which is going to finish the model in approximately just a few seconds here. Looks like a total time of less than 25-30 seconds. It'll finish up. We're just taking a look at the actual precision, and there it is, finished within an STL is ready to go. This is no longer than 6 minutes, and that is the exporting feature right there. The next step, just to show you the precision of this actual scanned data, I'm going to drop some measurements on here and show you how actually small this part is. 0.1 to 0.2 is 0.65 millimeter. We'll save that. We'll go into another scan, another measurement, 0.1 to 2, and we'll do a third measurement from the next point where you might set a gem in there. And you might just click all three of those. You can see they're 0.7, 0.65, and 0.81 millimeter. Very small, accurate, and enough, I believe, this was in the Smart Fusion and not even the Sharp Fusion process. There is another aspect of measuring the entire volume of the object. Measure the entire volume right there, entire model. You click calculate, and it's 221.93 millimeters of volume. The next step I decided to show you here is these holes. Let's say it's all messed up with this holes in the back, and that's not going to help you in Rhino or any other CAD software. You want to get rid of these holes. You can do this bridging where it creates a algorithm line for feature of what it scanned. It's calculating the best it can the features of which you've drawn the bridge, meaning point A to point B, and you can adjust the curvature based on the other geometry around it. Simply create bridge, click bridge, and then you have a piece of geometry. You can now reduce the size of the hole. The next step would be is go back into the holes, and you can actually fill all holes at one shot by selecting all, click apply. And we'll do that one more time here, select all, click apply, and every hole is filled. Now, I still don't think that's very clean, so the next step would be just to clean up that mesh real quick for Rhino, so you have a nice clean mesh to start building your actual gem mount, or however it mounts the gem. I just want to click and select and show that you can get different angles. This thing was set up in a parametric, a orientation with it was aligned with the left, right, and top and bottom orientated. I simply select with the rectangular selection, delete it, and go into the hole filling, and then simply click the hole fill, and there's a nice clean, like bullet looking mount. You could then finally export this again by going back into the final model. You can right click on the linear measurements, and you can also export those as XML and CSV. Take a look. There it is, final model, and let me know what you think.